Guys, so in this video I'm going to be explaining skewness and just the basic principles of skewness. So I've got two data sets which I'm going to use to do this. So I've been out and I've collected, the first one which I used was I collected these family ages. So I went out and I found this random family and I said to them, hey, you guys look like you'd be good for my data set, can I ask you some questions? So I did, and I said, how old are you? So this is the ages of this family. So there were 4 grandparents, and they were aged 80, 81, 80 and 82. There were 2 parents, aged 49 and 50, and there was 1 baby, and that baby was age 1, but it couldn't talk back, so the parents told me the baby was 1. So, with this data set, we can see automatically that there is quite a few values up in this high range, a few values in this mid range, and very few values down in this low range. So if we were to draw this up, we could go over to our axis and say, okay, we've got around about the 80 mark, then we've got values at around the 50 mark, then we've got values around the 0 mark. And we'll plot our data. So the grandparents, we had 4 of them. So we had 4 observations, and they were all around the 80 mark. Some a little bit to the left, some a little bit to the right, sorry. So we had 80, 81, 82, and then we had another 80. Space these out a bit more. So we had 80, 81, 82, and 80 again. For the parents, they were aged 49 and 50. So here on this axis is my mark of 50. So we've got 49, which is just a little bit below 50. And then we've got the age of 50. And then for our baby, we've got our 1 observation right down here, just a little bit past 1, and we've got this 1 observation. So what we notice is that the data isn't all around the same point. We've got this big wide open space here where there are a few observations, or no observations, and then this tiny observation down here. And if we were to, say, draw a curve around this, it would look a little bit like this. So it would be flat, and then it would peak, and it would peak like that. So that's what our curve would look like. And we'll notice that this is not the symmetrical curve which we're used to seeing. So it's kind of got a really long tail down here to the left, and then this big wide data point up here to the right, where most of our observations are. So what we refer to this as is we call it a negative skew. So there's really no easy way to remember negative skew, but there are a few properties which do give it away. So the first one is that it's got very long left tail. So it's got this long left tail, which we've got here, just down here, with most of our observations being at our right, and we've got this long tail here. The other one is there are few observations which are low. So there are few low observations. So we can see that here. We've got the baby, which is giving this distribution the negative skew. So I'm not saying that the baby is negative, but the baby is definitely what gives the distribution the negative skew. If the child was, say, 25, then the distribution would be far less skewed because the marking would be up here. But this baby gives the distribution the negative skew. So that is our negative skewness. So I did another data collection. So I went and I asked a bunch of children. So I said, children, how old are you? And they said to me, they told me their ages. So we had one said 4, the next said 4, then 4, then 4, and 5. And we had one child who didn't know quite how old they were, so they just had a guess and said they were 150. So this was the child that didn't know. So this child did not know, so they told me they were 150. And I didn't want to bias the sample, so I just wrote down what the child told me, and that child for all intents and purposes, was 150 years old. So what we want to do is we want to draw up these children's ages onto a graph, sorry, and see what they kind of look like. So we know we'll have a few ages around this 5 mark, but then we've also got some ages up here at around the 150 mark. So if we want to draw this on, we'll see that we've got one child who was 4, 2 who are 4, 3 who are 4, 4 who are 4, one child who is 5, so put that next to it, and then we got this one child all the way out here who thinks he was 150 years old. So what we can see is that the data is in no way symmetrical. It's kind of got a lot of data to the left and not much over to the right. So if we draw again a curve around this, we'll see that we get kind of this happening, with a lot of our data to the left and not much of our data to the right. So this is just the reverse of the negative skew, if we have a look at it. And there's no prizes for guessing that this is indeed a positive skew. So a positive skew has a few distinct characteristics. It's got this really long right tail. Here. And the reason we have the long right tail in this case is that we have this one child who didn't know how old they were. So they've told me they were 150, so they've kind of thrown out our data set, and we've got this skewness. So we get this really long right tail. And the other property is we see few high observations. So we got few high observations. And in this case we can see most of our observations are low, down here around the 5 years old mark, but some are quite high. We've got one which is quite high and gives us the skewness. So that is skewness in a nutshell. Like I say, there's no real easy way to memorize it other than to just say understand it, but perhaps maybe try to learn one and the other is just going to be the reverse. So it's not too difficult. Just remember, a negative skew has a long left tail, positive skew has a long right tail. So that is negative skewness and positive skewness. There'll be some examples go up. Thanks for that, guys. I'll see you next lesson.